We're going to continue looking at probability distributions with the binomial probability distribution. So the key concept here is we're going to be focusing on the binomial probability distribution rather than just probability distributions. And we're going to look at all the different methods for actually determining these and then interpreting them as well. So this is the vocabulary that we're going to be looking at. We're going to look at what makes something a binomial probability distribution, the notation, the 4 different methods to actually calculate, and we're going to be focusing mainly on Excel and our TI-84, though we will be using the table and formula just for practice, and then using the mean and the standard deviation. So formulas, and then of course going back to what's significantly high and low. So we had criteria for what makes a probability distribution. We have different criteria for what makes something a binomial probability distribution, and there are 4 basic criteria. 1, it has to have a fixed number of trials, can't go on forever and ever. The trials must be independent, meaning that any individual trial doesn't affect the other trial. So essentially we're having replacement, if you will, like we're not taking something and keeping it. Each trial must all have outcomes classified in exactly 2 categories. And this is super important here. Success and failure, what we want and what we don't want. Instead of rolling a 1, 2, 3, 4, 5, 6, that's not binomial. Think of binomial as 2. It would be either rolling a 3 or not a 3, or rolling an odd or not an odd. So we're basically kind of saying what we want versus what we don't want. And then the probability of success remains the same in all the trials. We've got important notation here. We'll use a capital S and capital F for success and failure, but usually what the most important ones is the probability of a success is P, the probability of a failure is Q, and N is the number of trials. So these are super important variables because we're going to use them in all of our different methods. So again, here we go. X is going to reference the number of successes. So this is important, the number of successes that we're looking for. Again, P is the probability of success, Q is the probability of failure, and N trials. Okay, so when we think of success in real world, we think of good things. But when we're talking about success here, it's not necessarily a good thing. It's just what we're looking for. So don't let success's positive connotation kind of throw you when you're looking at something as a success. Something getting damaged can be considered a success here if it's what we want. All right. All right, so example 1, when an adult is randomly selected with replacement, there is a 0.85 probability that this person knows what Twitter is. Suppose that we want to find the probability that exactly 3 of 5 randomly selected adults know what Twitter is. Does this procedure result in a binomial distribution? All right, so let's take a peek here. There's some criteria that we have to see. So let's go back to our list. So the procedure has a fixed number of trials. Is there a fixed number of trials? And yes, 3 of 5. We're going to ask 5 people, so yes. The next thing we want to know is it independent? And it said with replacement, or in general, sometimes you can kind of assume based on the story that yes. And the next one is, are there 2 things, success and failure? So let's think about this. They either know what Twitter is or they don't. So it's no or don't know. So that is 2 things, success and failure. And the last one is the success the same? And yes, this probability doesn't change. So yes, this is a binomial distribution. So if it is, identify the N, the X, the P, and the Q. So the N is the number of trials, the X is the number of successes we're looking for, P is the probability of success, and Q is the probability of failure. So how many people are we at? How many trials? 5. How many are we looking for? 3. P is 0.85. Now, how do we calculate Q? Remember that the total of probability is 1, so Q is actually going to be 1 minus 0.85, or 0.15. If you know P, you can figure out Q and vice versa. If you want to read a little bit more about how we figured out A and B. Again, just remember, success is a concept. It's not an actual, like, this is successful. So go ahead and give these 2 a try and press play when you're ready to see the answer. And there we go. Remember, we've seen this before, that when we select a sample with really, really large populations, we can treat dependent events as independent if the population is super, super large. All right, so let's actually get into finding binomial probabilities. So we've got the formula, we got the calculator, the table, and Excel. And again, we're going to be focusing mainly on these, and you're most likely going to like Excel the most, but you'll get to peek and see why. All right, so we have a probability formula. Now, these are actually the same. Why? Because this section right here, this is the formula for a combination. So we've done combinations before, so and I'll show you how to use those in your calculator. Now, I don't think I showed you that before, but you can use your calculator, just type this whole thing in. Okay. So given that there is a 0.85 probability that a randomly selected adult knows what Twitter is, use the binomial probability formula to find the probability that when 5 adults are randomly selected, exactly 3 of them know what Twitter is. So this is what we're using. We're using the formula. And so this formula, we need to know N, X, P, and Q. Well, we already identified our N, our X, our P, and our Q in the previous problem. So now we'll just type it in here. So that's P of X equals N, we're choosing 3, and then we've got 0.85 to the X, and then Q, you can do N minus X, 5 minus 3, or maybe just calculate it. So we're going to type that into the calculator. So if we want to type that combination, we start by typing the 5, and then we go into math, over to probability, and there we go. So now you're like, oh, now I can do this on the test. And the answer is yes, you can. Type your R. All right, so we get 10 times 0.85 to the third, times 0.15 to the second, and we get 0.138. So the probability here is 0.138. So that is one way you can figure it out. If you want to do the combination by hand, you certainly can. You don't need to use your calculator. And go ahead and give these two a try. And we're using the formula. And then press play when you're ready to see. So the next method we're going to talk about is using our calculator. So we can actually use the calculator completely by using the Binom PDF, and then we'll type in NPX. And your calculator may automatically go to the screen, or it might look like this screen. And it's okay, either one. If you just get this, you can just type in your N, comma, P, comma, X, or you can type in depending on what you see. All right, so it's the same question, but here they say use the probability in the calculator. So for the calculator, we need to know the N, the P, and the X. So we know that it's 5, 0.85, and we're still looking for exactly 3 people. So when we go to our calculator, we're going to go to second, theirs, for the distribution. And you can go up or down, but we're looking for binomial PDF. Make sure you do the PDF. And so the trials, oh look, I already typed it in. Trials is 5, scroll down 0.85, and then 3. Now, some of you might get straight to the screen. Just make sure you use the comma, which is above the 7, and then you hit enter, and boom, you get that the probability of 3 is equal to 0.138. So we can use our calculator, and that's a little bit easier. Go ahead and do the exact same problem. You've already done these, but now use your calculator. And there you go. So when we come back in part 2, we're going to do the method using the table and the method using Excel, and then find the mean and standard deviation. So that concludes section 5.2, part 1.